So I came across this challenge recently called What Lies Within. It's pretty cool. It involves steganography. So you're given buildings.png, and so seemingly it's just a picture of some sort of big cathedral or something in a city. So there's not really much you can find out by doing analysis here. If you split the color channels, there's not much to see. You can't really pull any strings that way. So there's probably a message being hidden within the bytes, something that's been encoded, steganography, which cannot be decoded easily just from stripping it from the image itself. So we're going to look up steganography decoder online. There's this tool called appearresolve, which does a lot of this for you. So we're going to put in buildings.png, and we're going to submit. And so yeah, so we get a bunch of stuff here. This isn't really useful to us unless it's a visual flag, something that's been visually put in there, which is not the case. This is just a bunch of garbage. So there's a tool called zsteg, which will do a lot of try to find hidden messages. So the way zsteg works is this is the flag that was extracted using these parameters for zsteg. B1 means we're going to go 1 byte at a time, right? The number of bits to iterate over, and we're going to search through red, green, and blue color channels. We are going to specify that the least significant bit will come first. You know, left to right, right to left, and then the order should be X, Y. And so with those parameters in check, we extracted picoctf in the flag. So this is pretty cool if you want to learn about, if you want to dive more into zsteg to figure out how steganography works. You can play around with the different parameters if you have an image with some hidden data. So yeah,